Yes. Uh, so good morning, everyone. Today we have like 9 people joining us, which is a good number, and I think there is no one else waiting to join. Unfortunately, Professor Raj is not able to make for today's session, but yeah. So let me get started. So today I'll be talking about this paper, reproducing whisper style training using an open source toolkit and publicly available data. So usually there is a section to introduce everyone. A bit about myself. I am working as an ML engineer at servam.ai, and I'm a volunteer in another as an open source volunteer in another open source community called Swatantra Malayalam Computing as well. I have been I have spoken in multiple conferences like PyCon India, Force Asia, etc. in the past, and I do maintain some open source packages as well. So onto it. Usually face this problem. Let me see if I can. So this paper, abstract of the paper, it is so this is a paper and what it tries to do is like there was this wonderful paper by OpenAI called Whisper, and it was like a multilingual multitask model which was trained on 680,000 hours of supervised speech data, and it generalizes for various speech recognition and speech translation setups. So it is not just a single model, but it's a multilingual model. And this model was like a game changer in the speech world. And pre-training speech models on large volumes with Whisper has shown it. So once Whisper did this thing, a lot of other companies like Meta also started rolling out some models. But what this paper is trying to do is like the usually papers like OpenAI or something like that, they do uh, what do you say? They open source the model weights, they open source the code, but they never open source the data pipeline or how it was being actually trained or the training scripts. So they are trying to publicly reproduce it, and if it is not being open sourced, it is making it is hard for the researchers to improve performance or address biases or fairness issues, etc. So open whisper style speech model is basically reproducing the whisper style training using open source toolkit and publicly available data. And OWSM even supports more so OpenAI Whisper was for like close to 99 languages, but this supports even more languages, more translation directions, and is more even efficient to train is what they're claiming. And they has promised that they will publicly release all the scripts used for data preparation, training, inference, etc. And as far as I know, they have released it as well. Even though I haven't looked into their code, this GitHub repository called ESPNet, I think they have released everything publicly as well. And about the authors of the paper, if you look at the authors of the paper are Yifang Peng, Jin Chuan Tian, Brian Yan, etc. So they are from CMU University in USA, and a bunch of others are from China. Some of them are from Honda Research in Japan. One very interesting direction from here onwards, like I don't have prepared much slides, but I have went through the paper. So I kind of, okay, if you look at the paper in general, one very important thing what they have done is the data preparation aspect of the Whisper. So Whisper is pre-trained on 680K hours of label data. And they usually collected data set with their open source toolkit. And in total, our largest data set was compared to 680K hours, it was like 180K hours of labeled audio data. And OWSM V1 consists of datasets like AI Shell 1, COVOS 2, Giga speech, Libri speech, Must 2, SPGI speech, and Tedlium. Tedlium and all are like data sets. So all this, if you can want to check in detail, you can. Like Tedlium, as far as I remember, it is like twice as much data. It's also a paper that it's a in this paper, I think they release the data, and it's like TED Talks or something like that. So that is the data set which was being used for OWSM v1, and OWSM v2 has like all data in v1 plus Giga ST, multilingual library speech, and VNet speech. And OWSM v3 has AI data lang, AMI. AMI is one very good data set for evaluation. Then Common Voice, Fisher, Calhoun Net, Louvers, Google IGN Net, Case on Speech, Magic Data, Riosen Data, Russian OpenSTT, Voxwatch, etc. I think someone is talking. Maybe can I just mute them? Fine. Please do unmute if anyone else is talking. I hope I am audible. If you want to raise ask any questions or something, maybe you can ask, raise the hand or something like that. That option should be there, right? Then like we can discuss further as well. So this is the data which is being used for the model, and the Whisper, the architecture of the model architecture, it's nothing complicated as well. So I kind of the model architecture is they have followed. If you have read the Whisper paper, maybe I can just open the Whisper paper also similarly. Whisper paper, yes. Whisper paper also follows this multitask training format. And this also is following the multitask training format. The only thing is SOP, previous tech, SOS. There is a tag for language identification, then two directions, ASR as well, speech translation. In ASR, there is speech timestamps. Here also, there is a transcribe tag, there is a translate tab. In this transcribe tab, begin timestamp is there, end timestamp is there. In the translate tab, there is no timestamps. And this is the approach which is used for multitask training format. So the architecture, I think, is exactly the same architecture as Whisper. There is no novelty in this architecture per se. And I think the only novelty, if you look at tables and all, like, okay, the data is the main thing. So in data, I think English ASR, it is in K hours. So total hours for V1 was totally, I think, 38 hours for 22 hours. The total hours was 38K. V2 was 129K. V3 was 180K. And they had some good focus on collecting multilingual data and translation pair kind of data. If you look at OpenAI Whisper, 438,000 of his hours was English ASR data. Multilingual was 117, other was translation. So this was it, and then the model parameters, like how many millions of parameters it was, hidden size, training size, all those things. So this is, so the architecture wise, I won't say there is much difference at all. Training details as well, they have mentioned like it is trained on NVIDIA A100, and I think it was 1A100 or something like it. You see, OWSM VS1 was trained around 7 days on 32A100. V2 and V3 was trained on 10 days for 64A100. So it's obviously an expensive setup, but they have told it for how much setup they use. While in Whisper, we don't even know it. So I think this direction, I didn't find much interesting, but maybe the results and the experiments it did was something I was actually interested to learn more about it and how well it is performing. So maybe I can take a pause. If anyone has any questions till now, maybe we can discuss. If anyone has any questions, do let me know.
In the data sets, how does the speech data generally look like? Is it like chunks of like some voice audio clips or? like a big audio clip, or how is it formatted?
Usually, Whisper is trained in chunks of 30 seconds. And if I remember correctly, here also, good question actually, because even I didn't think about it, but I have a hypothesis that it might also be trained for 30 seconds, but let's just check it. Let's see if it is saying anything about 30 seconds or something like that. Let me,
Yeah, Manish, I have a question too, right? So if you look at the results, oh, sorry, you were doing something first. Why don't you?
yeah. Let me just complete it. So each long form is limited to. So I think your question, right? So data format, how it will be like each long form return. So if it's like a video of 60 minutes or something like that, it is limited to a maximum duration of 30 seconds, and then we train it. So 30 seconds corresponding text to a 30-second audio, corresponding text we will align it, and then we will correspondingly do it. And all during the training, all utterances are padded precisely to 30 seconds. So I think this 30 seconds, which is being used in Whisper, is also being used here as well. Does it answer your question, Yash?
Is 30 seconds like the context, like in terms of LLMs, generally there's like a context window, right? Like I
Hmm,
am new to these speech models, but
correct.
is 30-second like the context window here?
Mm, I think so. I am not sure exactly to say, but yeah, one thing I have noticed when looking at the audio domain in general is most of the models are trained only for this 30-second duration. Why? Even if it is a long for transcription audio, how we usually train is like model will be trained in 30 seconds, but then they will use we will then like batch it together or use some smarter chunking algorithms like WhisperX or something like that to present it. But your question on why 30 seconds, is it like similar to LLMs in context length? Uh, I'm also not exactly sure. Maybe I have a guess. Maybe because of the deep learning, audio is more verbose than GPU, like the text kind of data. So because of that, if it is too much data altogether, maybe fitting in the GPU RAM might be too much. But that's my guess. I'm not sure.
Okay, okay, yeah.
Yeah.
So
Uh,
is Whisper um, like a decoder only kind of a model which is transcribing
so Whisper is an encoder decoder model.
encoder decoder model?
Yeah.
Yeah, I see.
It
I see.
takes
So the whole sequence is first encoded, and that is provided as a context to the decoder.
correct. Exactly. And so
Okay,
basically, yeah, encoder does this in this, I think, multitasking, and then decoder finally, yeah, predicts it. What is the next word kind of thing.
I see. I see. Okay. All right. So my question was, if you go to the results table, yeah,
Which table? This one?
the results table, yeah, the one where you were, no, the next one, if you go,
This one,
yeah, this
right?
one over here, yeah,
Yeah.
yeah, these error rates, right? So question over here, right? So we talked about the data, right? And the data, it's a
Hmm.
mix of various different data sets, yeah,
Yes.
and right, and it's smaller than what Whisper used, right? Maybe not, I don't know, maybe of the order of 50% or less or something like that, but maybe not 1/10 or whatever, something like that, right? So because
Maybe
they come up to
yeah, 1/3 or something like that, because this is 180 and other is like, okay, approximately 1/3, I think. We can guess with that.
correct, correct. So okay, very good. So I think when you set up that kind of a thing for training, I mean training, it's up to you, whatever you want to do, right? Kind of a
Hmm.
thing. Yeah. So I have a few questions, right? So one question is of testing, right? So what is this tested on, right? So is there a generic benchmark, right, which is outside of this training set and so on, right? On which are they saying that they're dividing their own data into training and testing their testing Whisper on the test set that they have created? Yeah. What is the testing setup?
I think test for each the data set which we have listed, right? I am pretty sure there will be a test set also for it. So yeah, there will be a training set, then there will be validation set, then there will be a test set also for AI shell one, all these things as well.
Yeah, yeah. So
And
one of the
then
things is that, yeah, go ahead, yeah, please. Yeah.
And your question on what is it being evaluated, probably metrics
Correct.
like word rate,
No, no,
CER, then
metrics is fine. Metrics is
yeah,
fine. I'm not
yeah,
talking about metrics. I'm just talking about, see, okay, where I'm coming from, right?
yeah,
So let's say OpenAI, right? They're creating a model and they're thinking that this model should work out of the box, right? In general settings like the one we are having over here, right? It's not data in a specific setting, right? Yeah, okay.
mm,
And that might be a harder test set or whatever testing condition for the model, right? And you take that particular model and put it into a simpler testing condition, right? Let's say, I'm hypothetically, because I haven't read the paper, yeah. And then you're saying that, okay, I'll compare OpenAI Whisper on a simpler setting, right? And my setting is simpler, right? All
mm,
that is fine, but then, a particular person in the industry, right? See, your test set is always a surrogate for your deployment conditions. Yeah.
correct.
Question is that, what is a good test set, right? And is that a fair test set for deployment conditions, right? So that's where my question was coming from. That is there a general benchmark or whatever testing data, which is a leaderboard or whatever? We say, okay, we are just going to test on that training, whatever we can do, right? We can do. So yeah. Then the second thing that I would say is that's one question. The second question that I have is that, okay, point that they're making is that they're using general in the standard Whisper architecture, right?
Mm,
All they're doing is that, so Whisper is not available for everybody, and they're creating this open source kind of a version, right? Of
mm,
yeah,
correct.
okay,
It
yeah,
is
and
not available. Like they are like it
yeah,
is available for everyone, but they are like trying to create an open source version where the training is also open source.
correct, correct. So my
Mm,
question is that, okay, another question that I have is that seems like there is when you presented, there's no novelty even in like say training it and so on, right? So I would say that, okay, sometimes what happens is that you take the same architecture and so on, you have a different data setting and you kind of start innovating over there. So with a smaller data set, they're roughly able to get the same performance, right? Yeah. Uh, is that a takeaway from that particular table, that they're roughly able to get the same performance? Because you see,
no,
Whisper
they are not
Medium.
able to. They are not able to get the roughly the same performance. If you look here,
Hmm, yeah,
okay, some cases I think it's okay.
yeah,
So
English.
this in English, I think yeah, they have got better word rate, but this is just one metric, right? And I think
Yeah,
uh okay, if it's a generalizable or something like that, it's always a very good question because you see in this much benchmarks, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 benchmarks, OpenAI Whispers Media is better. Only in 3 benchmarks, OWSM V3 is better. And that too, it is a multilingual library speech and these data sets when they compare apple to apple.
can we quickly go back to the data table, right?
Yeah,
Yeah,
yeah, yeah.
okay.
Sure.
Yeah,
This
so
one, right?
here if you look at, yeah, but I'm trying to see, how much. Okay, so English ASR, right?
Yeah.
And yeah, so do you have 438 versus hours of data versus say V3 is 73. Multilingual, it's 117 to 67, right? So they
Correct.
have lesser English data and they are getting a better performance on.
Yeah,
So
it
it's
is
very
not
confusing
always.
as to what's happening.
Yeah, but I think this
Language.
word rate, I think, okay, it's just 3 word rate points. Sometimes word rate as a metric itself, evaluation in, okay, we have to use something. So that's why we are going with word rate. But sometimes this
Yeah,
word rate itself is sometimes unreliable and especially they use this data set, right? And I think, but in a generic thing, will it work or not? Here, because
okay.
here, if you look at this, Tetlium is, I think, a very good data set for long form ASR speech
Testing, yeah.
recognition. And I think V3 is getting only 9.2. Oh, they are even, even with more data, what they are seeing, this is actually a very interesting observation. So 67K to 73K, actually the performance got worse rather than improving, right?
Yeah,
Yeah, it is. Oh, that's right. It actually got worse rather than improving, which is sad. So all
yeah,
these things actually, oh, so even this is saying that even the kind of training data which we put also matters a lot, right? So yeah, I think, but yeah, I think this is kind of, but generally I was just looking, okay, whether few things with training data improvement, will the word rate increase or not? I think the word rate increases, decreases, basically OWSM V1 to V3 when 22K to 67K, it scaled up and increased to 6.0, but in 73K, it decreased slightly. But that's
yeah.
okay. 11.7, 11.7, it was through 13.0, 14.1. So yeah, I think In some cases it's good, but in some
So
cases
you
it's
you see so this data that they are, so this hours that is like the training data hours, right?
correct.
Yeah, so if you see, like, all the other languages, their training data is quite small. I mean, 73K they get for English, but Spanish it's only 2K, right?
Correct.
French is 2.5, and then it goes down. Polish is 0.3 K, right? So,
Correct.
okay, got it. Okay. Hmm.
Yeah. It also maybe this thing itself, if we look at it, maybe we can get a rough idea on. Okay, so Polish, this OpenAI guys had 4.3K. So
Yeah,
0.1K to 4.3K, you can see that the border rate is increasing from 37 to 300 hour, 37 to 6.8, which is a considerable thing. So data
yeah.
scaling works, but I think one takeaway from this paper for me also personally is like how you plug and play with the data is also very important. Maybe
Right.
that even I think somewhere in this paper or discussions. Oh no, I think it was in the so this paper itself has a next version as well called OWSM v3.1, and in that paper they said like you should be very careful when working with data, kind of thing they said. uh, but yeah, that's one direction. Yeah.
Hmm.
So yeah, I think we did look through. So this then I was also planning to maybe this border rate see thing after that. Kind of my section was this, and even let's look at this ground truth as well. So in examples of a ASR on a 30 segment generated using greedy search, utterances can be segmented, but the predicted tensions are usually okay. Okay, so this it is saying that okay, in this particular sentence, I'm going to talk about energy and climate. But certain sentences, the word are like the timestamps also, timestamp accuracy also, which they look, and sometimes they notice it's a bit wrong compared, right? Differences between reference and the predicted, they have like actually calculated it as well. Uh, that's also very interesting stuff.
Mm.
Another thing was the speech translation stuff. Speech translation also, if you look here, there is Whisper basically supported two kinds of speech translation, X to EN and EN to X. This thing is actually wrong, actually, in my opinion, because even though OpenAI Whisper paper says that they don't support EN to X, if you actually play with EN to X, you will see that like you can get it, but it is my opinion. So I don't think maybe they ignoring it is not correct, because I have played a lot with Whisper and sometimes EN to X works. X to EN obviously works, that's a non thing. EN to X also works in my opinion. So ours here they have put nil, but obviously you can get some metrics. But here they see it like okay, EN to X, what is the accuracy possible? Chinese, what is it possible? This is covers 2 is also another X to EN kind of data set. What is they are not able to beat so this is like blue score, which is a metric used for translation. Higher the value, better. Unlike in word rate, lower the value being better. In blue score, higher the value being is always better. And in blue score, they are not able to reach the levels, but we can't even complain also, because the amount of data they have is also less. So that is about the blue score and the speech translation stuff. So I think that's all roughly I had in mind, like multilingual speech translation, and so looking anyone else is interested in looking any other tables. So that's all. And generally, I found this paper. I want to check the source code also soon. But I found like okay, this discussion. So this works as like okay. First of all, it's a very openly acknowledging, even though it supports more languages, and this multi training, it is still falling behind Whisper. And even they have another version called OWSM v3.1, where they prove that in transcription they are able to beat. So there, what they have done is like I have read the paper. The only difference is like they use the same data, which is this OWSM v3 data, but instead of this encoder decoder model, they use something called as branch former or something like that. So branch former, if you use it, like you can get even better accuracy. But that paper also, I will say the accuracy. So they say that okay, they kind of went with a different thing, but that also how much good it is, like real world, I haven't played it, so then only I can tell it. And he says it's the training set is significantly smaller, but it is still 180K hours. Then like okay, they leverage public thing, all those things. So roughly that is what I
Are
what I
are
want.
you working on, are you in your company, are you trying to create a speech model?
Yes,
Okay, all right. Okay. So I have a question right over here, right? So I mean, maybe faster training mechanisms via, and there are the people who might know much more about this than me, right? So it's like LoRa kind of, or K-bit or 4-bit or this or that, right? Those kind of things might imply a reduced load on the training compute, right? The training compute that is needed, right? So the number of GPUs that they used, right? Yeah.
correct.
Yes. So have people been trying this in speech as well, or
I have seen this Laura Whisper something. I have tried Laura Whisper. I
yeah,
haven't.
there
Okay,
you,
there's a paper also. Okay, I have never
yeah,
tried.
yeah,
I
correct,
have
correct.
read it, but like I will read it. But I have seen
I
some.
mean, just to compare, how much, what are they, uh, communicating in terms of how much time it took, what their, you
Yeah,
know,
yeah, yeah, sure, sure, sure.
training
Maybe
setup
we can
was and
check
so
it out.
on.
So
Yeah,
Whisper is a powerful, nevertheless,
left, yeah. Mhm.
parameter.
Yeah. This experimental setup, right? If you click on that, we go over there on the left plane, left here, three, I think. Yeah, that's fine.
Section three,
You were
right?
there.
Experimental setup, right? Okay. Yeah.
Maybe it gives you.
Okay. Pef configuration, Whisper tuning.
It goes to results
So,
and analysis.
so they have something like full fine tuning versus Pef on Whisper with different amount of data adaptation. Uh, oh, so they are claiming. Uh, okay, what is this 1K, 10K, 30K? I think 1K probably data, right? Or maybe I think this might be it. Let's check this. First of all, let me take this paper in a proper PDF kind of way. Uh, it's called sparsely shared flora, right? So
Yeah.
sparsely shared flora. Okay. Hopefully this might be it. Yeah. No, wait. This is just a format. Okay, this is what we wanted to check, right? So full fine tuning versus PEF with Whisper with different amount of adaptation of data. Is at C1. Is at C1. Full fine tuning on Whisper large 2 is not conducted. Full fine tuning on Whisper large. Okay, large is not conducted because of limiter. Okay. So. I think I have to read a bit more. Maybe can we read it together?
Yeah. Yeah.
What is it saying? So let's look at the experimental setup. So experimental setup data set, the Chinese style speech with
Yeah, maybe what you can do is you can, put this link in the chat and people can open up on their side also, right?
can. Sure. So does work. Yeah. Okay. Is everyone able to access it now?
Yeah. Yeah, I don't think they have, or they give information of how many GPUs they use, right?
Yeah. That is one thing which we can say is a good thing about OWSM and all, because uh, they have actually been very truthful in their analysis. That's why I like their
Mm.
work also. Here, okay, basically, what is the conclusion? This paper presents a novel S2 LoRa to adapt this for S2 LoRa with fewer parameters more than existing. It benefits from the designs of fast learnable carried on low resource. Experiment achieves adoption and noticeably better performance only 0. While retaining only 0.02% training while using child features can benefit adoption in other large low resource speech recognition scenarios. Even I am also not sure. So whether it's faster itself or whether it's slower, whether obviously LoRa should be a lot more faster, right? That is the fundamental belief which people have been saying in LLM world, but how accurate it is, all those things. Yeah.
In context of speech models, what would zero shot mean? Talking about
So
zero.
zero shot means like what is the model getting without any prompting or without any yeah, I think default thing itself, like the zero shot is very widely used basically in this whisper paper. Sorry, what am I doing? I'll show you zero shot. Yeah, so the goal of is to develop a system to study this. We use as internet whisper in a zero shot setting without using. So basically, not fine tuning. That's all. The base model itself. What is accuracy? So, yeah, that is it. Here also, here we saw zero shot where. Okay, this is it. That's short request further improvement. Okay, yeah. So I think Whisper is a powerful model, but so it's saying like, okay, the zero shot the default performance in low resource languages like Chinese requires improvement, and it is proposing child speech as a representative type of low resource speech leverage for adapting, and recent PEFT in NLP has shown to be comparable even better than full fine tuning. Our current PEFT have not been well examined for their effectiveness. In this paper, only parameter composition types of PEFT approaches such as LoRa, BIFNet are investigated as they do not bring extra inference. Different popular PEFT methods are examined. Particularly, we examine LoRa. At LoRa, they figure out learnable patients. Yeah, I think so that with much fewer training parameters. Oh, so basically, I think the result is with much fewer trainable parameters, it can achieve a comparable in-domain performance with this. Also, I have to, all these are looking like jargons to me right now. I have to read more and understand like what is Adalora, what is LoRa, and what is this table itself is saying. I think what it is trying to say is like, from what I understand, maybe this is my guess also, I might be wrong. Maybe on base full fine tuning or like small full fine tuning, the way it reaches this character rate is taking more time. While if they are using PEFT kind of things like large PEFT or something like that, from 10 it is reaching very quickly to low values. So maybe this is what they are trying to say, but not sure exactly. So even I am also new to it. Yeah.
So in speech model, is there anything like, can you, like at inference time, can you give the models example first and then ask it to basically maybe ASR or like translation of the next example? Is there anything like that? I
Prompting
meant
is
like,
there. Prompting is there, but examples, I think it's not there. By examples, what do you mean? Like, are you referring to
like in
something like prompting?
LLMs, it's like you can give some few short examples, right? In the prompt itself, you'll show it some examples of what it has to predict, and then there's a new example it has to predict for that.
I think it's possible. Yash, actually. So Whisper actually, if you look at the Whisper API, okay, Whisper API, prompting or something like that. It's Whisper prompting guide. It is having something in the transcribe itself where you can give the prompt, and it itself is saying like, okay, for names, or if you don't want certain characters, or maybe if it is certain names like Chinese names not getting correct, or if you want it to be follow some style, like okay, president and all. Okay, in the unprompted, President Biden is capitalized. How if you want to process a fiction person where President Biden is lowercase, you can just pass President Biden as lowercase and then it will follow it. So that kind of thing is there in audio models itself. Like basically audio itself is like an LLM, basically a transformer model itself. But prompting, I think it's not so good compared to LLMs and stuff like that, or people haven't still explored that much. That is the reality of it. Yes.
Okay, yeah, I'll check out this link.
Yep. There is even a better link actually. Let me check. OpenAI API, Whisper or something. Whisper post processing or something like that. It says. Yeah, timestamps long. Yeah, basically this prompting and how you can post process with this prompt parameter, this names and all, how to give, or if you want to follow the style. But one thing you have to remember, since it is like a GPT-4 base model, it operates only first 244 tokens of the prompt or something like that. So even if you pass more things, like it won't work.
Oh, okay. Can you paste this link in the
Can
chat or something?
Sure. 1 second. This thing, right? You basically want, yeah. I will just paste this also for you. And we discussed this paper as well, which is, it's very good that we discussed about this paper as well. Very interesting paper. I have to read as well a bit more, or if there is any similar pep works. So yeah, I think that's all from my side. Thank you everyone. If anyone has any questions, maybe we can chat for some more time. Otherwise, we can call it a
Yeah,
day.
one last question, right? So it seems like PEFT kind of ideas. I mean, especially the uh, the plots that you were showing, right? Yeah, those plots were more on the accuracy, right? Not on the time saved or the computational distance
This
saved, right?
is,
Yeah.
yeah, the left is obviously on accuracy. You're right.
Yeah, so
And
it's no, they're both like GSC2 SER and C1 SER, right? It's the same kind of a metric, right? Yeah.
exactly.
So yeah,
C1 sir and CR is like character, right? Basically,
character
like
rate,
word
I
or
know.
right. Okay.
Yeah.
So
Okay, very good. So it seems, I mean, I'm just trying to get a broad takeaway from this, right? Is that, you can even get better accuracy, right? If you were to try these that kind of training approaches, right? And
correct.
one would think that computational resources in some way, right, would be lesser needed as well. I don't know, right? I'm just trying to. So it seems to me that, if one is trying to, I mean, takes this now, whisper training, this thing is now available in open
Yeah,
source kind of thing. One of the important directions would be to try some parameter efficient fine tuning kind of ideas, right?
correct.
Uh, yeah.
Yeah, exactly. Fully agree with you.
Okay.
Definitely, I think this has a scope, obviously, but I think no one has like conclusively said, because this is one research paper. Uh, uh,
Absolutely.
yeah, whether if it really works or not, maybe when we experiment only we
True,
can say.
true, 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 true. I mean, yeah, so as we try things that we have to kind of see, the promise of something and then try it out, right? Or
Correct,
wait
correct.
for it to be verified by other people, right?
Yes, exactly.
Thank you.
Thank you, Manish. Thank you for your very wonderful questions. Does anyone else have questions? Yes, Ram, please do. I think Ram has raised hand. If you want to mute, you can mute yourself. Unmute yourself, sorry.
Okay. Yeah. Hello. Yeah. So I just about this LoRa paper only. It is interesting to find that they have not mentioned the family of GPUs they have used anywhere, because if there is 0.46% of reduction of parameters, 100%, and getting such a good performance, I mean, for all practical purposes, I think they should have mentioned the family of GPUs they have used. Perhaps Manish sir was also saying the same thing. I don't know.
Exactly. I
Uh,
think why haven't they revealed it is itself as a
they
question.
revealed it's
Yeah.
not clear. Yeah, so not sure.
Good observation,
Yeah, and
actually, because I think sometimes even I have also sometimes felt like some paper authors are not fully truthful on what they have done.
yeah. So is it still in process or I don't know because it's an archive paper. I don't know. Then I think earlier some other person was asking about input to the uh, uh, these whisper models,
Hmm.
right? So and he was, I think Yash was mentioning, he's new to speech technology, and probably he was asking more fundamental question like to transformer like machine translation or something. The input is text embeddings, word embeddings. Each word or each token is passed into the model at once. So in speech, what exactly is passed?
Hmm.
In some abstract sense or in simple words or a layperson's words, how the speech is cut into pieces or tokens. Perhaps was that his question? I just wanted to clarify. And
Yes,
if you
maybe
can
you
throw
can
light on that,
unmute.
it may be useful. Yeah.
Yeah, I mean, I just looked in parallel, like what's the architecture of Whisper. So I think their encoder takes some kind of audio file, and then decoder is on text only. But
Yeah. So it takes, uh,
like maybe can you feed like let's say some small audio files beforehand, and then the decoder gets like, okay, what's the perfect translation for this, and then whatever actual translation or ASR that you want to do, that will be the last portion of the audio file, and then decoder has to basically predict for that. And my question was on few
okay.
short, like how does that, like is there
Oh,
something similar here or what? Yeah.
He was like basically few shot kind of is prompting, and you were maybe actually few shot itself is it. I think yes, exactly. It's like few shot itself because you're giving some examples and it's trying to learn the thing, right? Like the Biden and all, President Biden, small caps. It is making it that behavior, right?
Yeah,
Yeah.
but like I also meant like the audio file that would also contain like some examples. Maybe it's a person who speaks in certain accent,
Ah, okay, okay,
and
okay,
there
okay.
are audio files for him, and then like okay what he meant here, like you have some transcripts for it, and then there was a new audio file, and you are trying to predict for it.
Yeah, I have never seen audio files like being used as prompts or like few shots to learn this. Uh, but yeah, why is it not possible is a very interesting question. So yeah, even I'm also not sure. Yes.
Yeah, I
But,
mean, I just came to this meeting, but I had never explored speech models that much. But when I saw this architecture, this question came to my mind. Yeah.
yeah. Got it.
okay. So one more interesting observation or question, I think, Mr. Kurian, or if anyone else is working on neural machine translation, I'm just sharing an experience I have come through,
Mm-hmm.
and if they have experienced a similar thing, they may throw light on this. So this table 3 in the paper that you have shown, sir was also, Manish ji was also pointing out about English. OpenAI Whisper was giving worse performance compared to OWSM V2 or V3, right? So but
Actually,
the number of hours that the data is huge compared to OWSM. So
correct.
a similar thing I faced recently training.
Mm.
So AI4 Bharat has shared Samanantar datasets and recently IndicTrans. So with earlier Samanantar dataset, so we are basically trying to train some English to Kannada translation models.
Mm-hmm.
So on an earlier Kannada English to Kannada translation model where there were 4 million segments, parallel segments,
Mm.
I was getting something like 16 blue score as the model converges. But when I take the recent IndicTrans dataset, which is like 23 million sentences overall,
Mm.
sentence pairs, the performance drops in terms of blue score.
Oh,
So,
really?
similar thing I see here. Yeah, I don't know why. Like two blue scores, it has dropped. I don't know. I have tried to increase the change the simple hyperparameters, but because of our limited GPUs and all, I think I'm not still able to explore fully. But in the paper also they have specified in their IndicTrans V2 paper also larger data set is actually pulling it down. So is similar phenomenon observed here, and anyone else has come across this? I don't know if you have come across or and because I'm surprised because these people also have not shared any rationale behind this, nor IndicTrans V2 people have shared the rationale behind such drop in performance. So I don't know.
I think what you said is
Anyone?
a well-known establishment, like established fact, right? Sometimes some data is like data in, data out, like what
So you think more noise has entered the data? Uh, the data has
it
become
is
more noisy.
maybe Ram. And also one thing, actually, let me tell you this. Take this. Basically, I'm not someone who trusts numbers like blue score or water rate or something like that. Uh, Personally, I'm someone who believes in qualitative results. Okay, water rate and water rate and character rate can say something, but maybe I was even tweeting today with Hugging Face folks, guys, your open ASR leaderboard is there, but according to me, large V2 is a better model than large V3 or some of the even the other models like Parakrit model or NVIDIA's Parakrit models per se. That's the only model I have played. So in maybe Ram, maybe you can just try maybe in your thing itself rather than only looking for blue score. Look for qualitative transcriptions, qualitative evaluations as well. Maybe that's one tip I can give. See whether,
Yes.
obviously, for paper novelty and stuff like that, you have to say some blue score is improved or stuff like that. But if you are really caring about production, I think you should care about this qualitative scores as well. And it's a sad thing that like even audio or maybe I can't comment about blue score, but audio, the word rate as a metric, especially in my mother tongue Malayalam and all, it's like 50 or something like that. But that model is performing sometimes decently also. So
Oh,
maybe
oh,
just a suggestion for you, just see with the data
yeah.
qualitatively also, is it increasing or decreasing. Maybe you can just take 100 samples or something, see if it is really improving the translation, some styles of translation, is it like, do you like it, do you not like it, etc.
Yeah. Sure. Sure.
So I kind of agree with that. Yeah, I think the word error rate and the character error rate and so on. I think that's more something that will be jarring if you see, right? And you say, okay, I can directly trust the metric. I don't want those. But then people also try some something like which you can post processing kind of ideas and so on. If you actually have a lexicon and so on, that you can include like that, or you can also include that in your training and stuff like that. Especially if you're focusing on a particular domain and certain kinds of errors are more important for you than the
Mm.
others, right? But I think blue score is a very indirect kind of a score. Basically, what it's trying to do is that you take some reference translations and so on, right? And then you say, okay, these are high quality translations, and generally, how similar are yours to there, right?
Mm.
So it's an indirect kind of a metric. I think if you're too far off, then one can say, and like uh, right? You go by Vinay or Korean, right?
Yeah, call me Korean.
Vinay, yeah,
uh,
okay.
you can call me Korean, Manish.
Sorry.
Yeah.
Okay, all right. Okay.
Yeah.
Yeah, so like he's saying, right? I think you cannot just go by a performance table, right? If it's like totally off in terms of the ballpark itself, right? You say,
Mm.
okay, so I need to improve that. But once you start coming closer, then you have to, because largely, what companies and so on, what you guys are, anybody does is focus on his domain and see impact on his, sort of business or customers or this or that, right? Yeah. That's what I would say. I mean, obviously, I mean, this in some sense it also speaks to the fact that maybe there's a need for a better metric. And if you are a research-minded person, then you say, okay, if I'm seeing something, I trust one model more than the other while it's lower on the metric, right? Then
Yeah.
you say, okay, there's a need for yet another metric, and I can work on that.
Yeah. Got it. Yeah, exactly. Not even metrics itself, like it's a complicated thing. Yeah.
Yeah.
Maybe you
But you
can
cannot
create a
you
new
cannot let
metric,
go of
Ram.
metrics either. Right? I'm
Correct.
saying that you
Exactly.
cannot.
Exactly. Fully agree.
Yeah.
Even sometimes, yeah, even though we go for this qualitative evaluation, we still have to have that metrics as well, as Manish said. So yeah, any last questions? Anyone else? Otherwise, maybe we can wind this meeting off. Okay, 20 seconds. I will wait. Otherwise, we can call off a day.
I just had a question regarding like I mean, if someone has to present, what kind of papers are like generally preferred? Like which kind of papers?
Any papers in AI domain, be it LLMs, be it voice, be it computer vision, be it any domains, yes, you can present. Probably the only thing maybe is generic AI term itself. And AI itself, if you have something in hardware or something, like anything is possible. Yeah, you can just post it in the Discord group. There is no hard rules or something like that.
Okay, like other topics in NLP apart from LLMs, that is also fine.
Anything is possible. I just said LLMs just because
Yeah.
that is a hype. NLP also, anything you can present. Yes.
Okay, yeah, got it.
Okay, then thank you for joining. We had 7 people, despite Professor Raj not joining. So great. Thank you everyone for joining and for your wonderful questions. See you then. Take care. Bye.
Thank you. Bye bye.
Bye bye.